reactions of alkenes. Learning outcomes. By the end of the lesson, students should be able to explain the addition reaction alkenes with hydrogen in the presence of catalyst, alkenes with halogen in inert solvent, alkenes with halogen in water, alkenes with hydrogen halides, and alkenes with acidified water. Comparison of the reactivity between alkenes and alkenes. Alkenes are more reactive compared to alkenes. Alkenes have carbon-carbon single bonds, while alkenes have carbon-carbon double bonds. The double bond is a site of high electron density that we call nucleophilic site. Therefore, most alkenes reactions are electrophilic addition. Electrophilic addition reaction of alkenes. First, hydrogenation. The reaction of an alkene with hydrogen in the presence of catalysts such as platinum, nickel, and palladium to form an alkene. Here the general equation. When the double bond react with hydrogen in the presence of catalyst, the double bond will breaking up and the hydrogen will add to it and form alkene. For example, here we have the 2-methyl propene, so the double will open and the hydrogen will add to it. Cyclohexene here, the double bond will open and the hydrogen will bond to it and form cyclohexene. Second, halogenation of alkenes in inert solvent. Alkenes react rapidly with chlorine or bromine in CH2Cl2 at room temperature to form vicinal dihalides. Here the general equation. The double bond will breaking up. The halogen will bond to the carbons. For example, here we have 2-methyl butene. The double bond will breaking up and the chlorine will bond to the carbons. Third, halogenation of alkenes in water. If the halogenation of alkenes is carried out in water, the major product of the overall reaction is a haloalcohol called a halohydrin. Here the general equation. The double bond will breaking up. The hydrogen from halogen molecule will add to the carbon and the hydroxyl from water will add to the other carbon, form halohydrin. For example, here we have ethene react with bromine and water to form 2-bromoethanol. The double bond will break up. The bromine from bromine molecule will bond to the carbon and the hydroxyl from water bond with the other carbons. If the alkenes is unsymmetrical, the halogen ends up on the carbon atom with the greater number of hydrogen atoms, follow Markovnikov rule. For example, here we have unsymmetrical alkene. Thus, the bromine bond to the carbon that has greater number of hydrogen and the hydroxyl from water bond to the other carbon. For example, here we have unsymmetrical alkene react with bromine water. The bromine will bond to the carbon that has greater number of hydrogen, while hydroxyl will bond to the other carbon. Here we can see the differences. Halogenation of alkene in inert solvent and in water. If in inert solvent, both halogens will add to the carbon-carbon double bond, while in water, the halogen will add to the carbon that has greater number of hydrogen, and the hydroxyl will add to the other carbon. Fourth, addition of hydrogen halide. Hydrogen halide, either HBr or HCl, add to the double bond of alkenes to form haloalkenes. Here the general equation, the double bond will break up and the hydrogen and the halogen will bond to the carbons. The addition of HX to an unsymmetrical alkenes follow Markovnikov rule.